Hello everyone, we will talk about iterators for container classes in C++. And because this is a long video, I split it into two parts. I will first talk about container classes and iterators. We need iterators in CPSC 131 and 335, both core courses for computer science major. Using iterators for C, C++ standard template library classes is typically expected during the coding part of any technical interview. If you would like to improve your coding skills, please join the ACM club and attend the practice session for coding or working group projects that can be added to your GitHub portfolio. The C++ standard template library offers a variety of classes for complex tasks, such as searching or sorting. A container class, it's a class in which each instance, which is an object, is itself a collection of items. For example, the list of passwords previously used by account holder, a list of previously visited websites, which is a browser history. A key feature of a good container class is that the type of item in the container can be changed easily. This is what we call easy reuse. Many different applications can use the same container class. So we have the list of passwords, which is a list of strings including white spaces, and the list of previously visited websites, which are the list of URLs. From the standard template library, I choose a class set because you study set in the mathematical setting. The set is a standard template library class in which items are of the same type and they do not repeat. In a mathematical set, we also have the restriction that the items do not repeat, and also the items must be sorted. We'll have the same restriction in a set. We need to include the header file set in order to be able to use variables of type set. Example of variables, so let's say that we want to have a set of integers, so we declare the variable first, and the variable first it's a set of, and the shell brackets we put integer. This is what we call template instantiation, so we have a set of integer values. If we want to insert a value in that set, because first when it's declared it's empty, we use the function insert. So the value of 4 will be inserted in the variable first. We also insert 8 and we insert -1. If we want to print the set, then we will see that the values will be printed in order. So first will be -1, followed by 4, and followed by 8. Items in a set object must be able to be compared using less than operator. For built-in data types such as in no problem, because we have it already built, but for the user-defined classes, the less than operator must be overloaded as a member function. Some members of the STL class. So we have the data member value type, which is a type of an element. We have the data member size type, which is a type for a positive integer. We have the function member count, which returns a value of type size type, has a single argument, which is a const reference of type value type, and the function itself is const because it does not change the calling object. It will return the number of elements which are equal to the target. The function erase, which returns a value of type size type, has a single const reference argument of value type, and it will erase the first occurrence of the element equal to the target. The function size has no argument. It returns a value of size type. It's a const function. It will return the number of elements in the set. The function insert has a const reference argument of type value type and returns an iterator. So we see now the type iterator. It will insert the value specified in the set. Container classes support iterators. An iterator is an object, so it's an instance of a class iterator. We'll discuss more about that. It allows a programmer to easily step through all the items in a container class and abstract the process of looping through the collection of elements. Any STL container class has a member function called begin with no arguments that returns an iterator. That iterator will provide access to the first item in the container object. Iterators over the same container can be tested for equality using the equal operator and inequality using the not equal operator. They are equal if their current items are in the same position, or they are both past the end of the container, and you will see that. There are other operators, but their result is undefined behavior, so better not use them. So just use the equal and not equal operators. Our examples will be using only the two. Iterators from different containers should not be compared with each other. Again, undefined behavior. Let's say that we have an object v. v.begin returns an iterator to the first element, and v.end returns a position after the last element in the container. Each STL container has an associated class iterator. The function begin will return an iterator to the first element. The function end will return an iterator to an imaginary position just past the last element. An iterator will behave like a pointer to an element in the container. Star of p returns the element referenced by this iterator and will access the current element. We can use the increment, which is pre and post operator, to advance to the next element. Most STL containers provide the ability to move backwards as well, with a minus pre or post. This will work for the list, but will not work for forward list. So because of that, we say most STL containers, not all. The general pattern to use an iterator IT for an object V is to initialize the iterator to the first element of the container. So we have IT equal v.begin. Then we check that we have not passed the last element in the container, and then we increment the iterator. And then we will have statements inside the for loop to access the item, the current item, which is accessed through the star IT. This is called left inclusive pattern. It comes from the math, where we write square bracket 0, then 100, then round brackets, to denote all the numbers starting at 0 and going up but not including 100. Begin will access the first element and will access an imaginary position past the last element. So because of that, we have not including end. The function end returns an iterator to mark the end of the collection, but that is past the last element. Once you reach the end, do not go beyond that using the dereference operator star. Iterators are used to indicate a specific position within a container. The iterator-based operator and method. Let C be a container of a base type, E be an object of this base type, and P and Q be iterators. C.assign P and Q will replace C with the contents referenced by the iterator range P and Q from P up to but not including Q. Insert P and E will insert E prior to position P. Erase P will remove the element at position P. Erase P and Q will remove the elements in the iterator range P, Q. Please review the STL documentation to ensure the elements are properly created and deleted. Each iterator in the standard template library has an ordinary version and a const version. The const version can be used when the program needs to access the elements of a container without changing them, and we'll talk more about const iterators. So the way you declare it, you use the container, which is, let's say, a list of integer, and then you use the scope, so colon, double colon, and then const underscore iterator, and then the iterator P. We'll see some examples later. Insertion and removals can cause all the container's iterators to become invalid. So one insertion is enough to make all the iterators for that container invalid. The same, one removal. When an iterator becomes invalid because of change to its container, it cannot be used until it gets assigned a new value. C++ specifies 5 significant categories of iterators based on their abilities. The first two categories, an input iterator and an output iterator, are specialized iterators for retrieving and inserting elements. The other 3 categories are forward iterator, bidirectional iterator, and the random iterator. And we'll discuss each of them. Each of these categories has increasing stronger abilities. So the input, followed by output, followed by forward, followed by bidirectional, and at last a random iterator has the strongest abilities. An input iterator is to provide a sequence of values from the container. For an input iterator P, the current element of P can be retrieved using the dereference operator such as x equals star of P. The variable x will get the current value pointed by P. The increment operator will move the iterator forward to the next item. The intention is that an algorithm that uses an input iterator will retrieve an element using the dereference operator, then will go to the next element by using the increment operator, and will repeat over and over again until the end of the container is being reached. The end of the input iterator element is usually detected by comparing the input iterator with another iterator which is known to be just beyond the end of the input range, which is the end function. For an output iterator called P, the current element of an output iterator can be assigned to such as the reference of P equal and then the element shape. The intention is that an algorithm that uses an output iterator will do an assignment followed by an increment over and over again until it reaches the end. The output operator itself can be used to retrieve those elements. So the output iterator usefulness is limited to the situation where some algorithm needs to put a sequence of elements in a container or other objects using an output iterator. A forward iterator is an object that provides a default constructor to create an iterator not yet initialized, a copy constructor, and an assignment operator. The dereference operator accesses the iterator current item. In some cases, the item is assignable, meaning it can be directly changed with an assignment such as dereference P equal and then the quotes shape. In other cases, direct changes of the item are forbidden. The ++ operator moves the iterator forward to the next item. The ++ operator can be used in prefix notation, such as ++p, or postfix notation, such as p++. Both versions will move the iterator forward, and both versions are function calls that return an iterator, which can be used as part of a larger expression. In particular, ++p returns the iterator after it has moved forward, whereas p++ will return a copy of the iterator before it moved. A bidirectional iterator has all the abilities of a forward iterator, plus it can move backwards with the - operator. -p operator moves the iterator backward one position and returns the iterator after it had moved backward. P - operator also moves the iterator backward one position, returns a copy of the iterator before it moved. For example, the const iterator for list is a bidirectional iterator. A random access iterator can quickly access any randomly selected location in a container by providing 6 new operations in addition to those of the bidirectional iterator. A random access iterator can also use a bracket notation to provide access to an item which is n steps in front of the current item. For example, P bracket 0 is the current item, P brackets 1 is the next item, and so on. A random access iterator can always be used as if it were any of the other type of iterators because it has all the operations. This concludes part 1, Container Classes and Iterators. Thank you for listening.